This class is about trigonometric identities, and we mainly are going to be looking at two identities. One is the tan theta equals to sine theta over cos theta, and sine square theta plus cos square theta is 1. Now you might have seen this before, but I think you will be new to this. The other two are just rewrites of this second one. Okay, so like 1 minus sine square theta equals to cos square theta comes from this, and 1 minus cos square theta equals to sine square theta also comes from this. And we will use these identities to simplify more difficult identities. Okay, now when proving an identity, this is a tip before we move on, meaning if we are supposed to compare two identities, meaning prove that one identity is the next, then we will start with the more complicated side, and it's easier to go from that to the simpler one than the other way around. And we'll see examples of that and where we will use this tip in action. Example 1. Express 4 cos square x minus 3 sine square x in terms of cos x. So at the moment we have cos x, but we also have sine x, and we want to change the sine x so that we only have the entire expression in terms of cos x. And from that, again, we're going to use one of those identities where, remember, we can change our sine square theta into a 1 minus cos square theta, which is exactly what we're going to do here. So our sine square x, we're going to convert it into a 1 minus cos square x. So we'll rewrite this as 4 cos square x minus 3, 1 minus cos square x. And that, we can expand this, we get 4 cos square x minus 3 plus 3 cos square x. And this at the end would be just 7 cos square x minus 3. Next, we're told to prove this identity, and you can see that the left side looks more complicated than the right side. Yes, and this is where the tip comes in, where you start off with the more complicated and try to prove the less complicated. So we're going to start off with this, and you see this is two fractions, and we want to add them together to get one fraction at the end. And so let's put these two fractions into one fraction first. And we know how to do that with fractions, right? We will cross multiply as well as multiply the bottom as well. And what this does is changes it into one single fraction. So what we will have is 1 plus sine x squared, because you're multiplying it by itself, plus cos x squared. Cos x squared. All of this over cos x bracket 1 plus sine x. Let's start with the numerator. 1 plus sine x squared is going to be 1 plus 2 sine x plus sine square x plus cos square x. Yes? And then all of that will be over cos x 1 plus sine x. Then what we have to do is we want to convert it into 2 over cos x. So obviously we need to find a way to remove this sine square x plus cos square x, and the way we can do is by using that identity that we did earlier, where this is just equal to 1. And so we will now have 1 plus 2 sine x plus 1 over cos x 1 plus sine x. And then we can rewrite this as 2 plus 2 sine x over cos x 1 plus sine x. And then now we might think that we are stuck, but remember, we can factor out the 2 here, and we would get 2 bracket 1 plus sine x over cos x 1 plus sine x. And at the end, what we can do is just cancel these out, and we will be left with the 2 over cos x that we needed. Next, prove this identity. Again, look at the more complicated side first, and this one obviously looks like the more complicated side because it has a square, 2 fractions, it has a tan x as well, while the left one looks quite simple. So we'll start with the right one, and firstly what I would do here is try to change those 2 fractions into one fraction, just to make everything a little bit easier, especially the squaring part. So the tan x, I'm going to write it as sine x over cos x. I'm going to add it with 1 over cos x, and this will just give us sine x plus 1 over cos x, because the denominators are the same. And then we want to square it, so we can square that, and we will get 1 plus sine x squared over cos x squared. And this is just going to be 1 plus sine x 1 plus sine x all over cos square x, right? Then we go look at what we want to prove, and we see at the bottom we don't have 1 minus sine x. We don't have a sine x at all, actually. So we would then get the idea, okay, maybe we convert the cos square x into something with a sine x, and we get exactly that because we know that this is just 1 minus sine square x. So at the end, we would get 1 plus sine x, 1 plus sine x all over. Remember, this is just difference of two squares. If you're good with factorizing, you did this at IGCSE. This is just a difference of two squares where we can factorize this as 1 plus sine x and 1 minus sine x. And then what we can do here is we can cancel out these two, and we end up with 1 plus sine x over 1 minus sine x, which is exactly what we wanted. Lastly, prove the identity 1 minus tan square over 1 plus tan square theta equals to 2 cos square theta minus 1. Again, this left side looks like the more complicated one, so we're going to start off with that. So, firstly, we know that we need to remove these tan thetas because we have cos thetas as our proving identity. So, we can make the tan thetas into sine over cos. So, we have 1 minus sine square theta over cos square theta, because this is basically tan square theta. And then this is the numerator, by the way. And then for the denominator, we have 1 plus sine square theta over cos square theta. And firstly, what we want to do is make this into one fraction, right? So we can make the denominator of this 1, then we can just do a normal cross multiplication and obviously multiplying the denominators as well, right? And for the top one, we would get cos square theta minus sine square theta over cos square theta. And then for this one, we would get cos square theta plus sine square theta over cos square theta. Now what we can do is multiply the up by cos square theta, the numerator, and the denominator by cos square theta as well. What this does is you will cancel out the denominator on both the numerator and the denominator, which will leave us with cos square theta minus sine square theta over cos square theta plus sine square theta. We know that this right here is just 1 from the identity that we have learned. And because this is 1, we will have 1 in the denominator, which means we will only be left with the numerator, which is just cos square theta minus sine square theta. Then we go back and look at the thing that we wanted to prove again. And we see that there is no sine in anywhere here. So we want to convert that sine into something of cos. And we have exactly an identity for that, where sine square theta is just 1 minus cos square theta. So we will have cos square theta minus 1 minus cos square theta, which will just be 2 cos square theta minus 1, which will give you your proven identity. Then for part B, this usually is a follow-up question when it comes to past papers, where they will tell you now to solve an equation, where they'll give you some complicated thing, and that thing will be very close or exactly the same to what you proved in the identity in the previous part. So here you see 1 minus tan square theta over 1 plus tan square theta. We proved it's the exact same as just 2 cos square theta minus 1. So we're going to use that instead, right? So this is just going to be 2 cos square theta minus 1 equals to 5 cos theta minus 3. And then here we have cos on both sides, so we can just solve this quadratically. We did this in our first lesson. So we're going to rewrite this as 2 cos square theta minus 5 cos theta minus 1 plus 3, which is just plus 2, equals 0. And then we can substitute cos theta for x. So let x equals cos theta, and we will get 2x squared minus 5x plus 2 equals 0. And we can solve this right here, and we will get that x equals to a half and x equals to 2, which means that cos theta equals to a half or cos theta equals to 2. We know that this is not possible because cos theta ranges from -1 to 1, so 2 is out of its range, and so we're just going to use this right here. Then from here we can get our first theta, which is just going to be cos inverse of a half, so cos inverse of a half, which is just 60 degrees. And to get our other theta, we know that we just need to do 360 minus theta, which will give us 360 minus 60 degrees, which is going to give us 300 degrees. And so these two are going to be the answers for our theta to solve this equation in this domain.